Alright guys, welcome back. Today we're talking about lesson 10-6, which is about circles and arcs. Okay, we're talking about circles and arcs. So hopefully you guys are at least familiar with what a circle is. So, and you may, obviously you know a circle looks something like this, right? It looks something like this. But to actually define it, I don't want that there. To define it, a circle. Well, how would you create a circle? You can create one with a compass, right? Where if you put your needle here, for example, and you put your pencil here, what would you do? You'd rotate your pencil around until it came back around. And the point of doing that is because each of these values here, each of these distances, is the same, right? And we call this a radius, right? Which we'll get to in a second to more specifically define that. But it's called the set of all points. The set of all points. Why do I keep doing that one? The set of all points that are equidistant meaning they're the same distance away from the center. And when I'm looking at the center in this picture that I have to the right here, the center would be point P, right? The center would be point P. So we would call this circle here, we would call it specifically, we would call this circle P. Whatever the center is, we would call this circle P because that's the center. And the notation for that, in quotes, we're going to put circle P here. But the notation for that you're going to see in a book and a test is a circle P. Okay, so this is pronounced circle P, and again that value of P, or that letter P, comes from what the center is. So if the center was K, it would be circle K, right? Anyway, so that's kind of the notation there for you. Now parts of this circle. So let's use this picture to the right here. Let's use this picture here to help us define this. One of the parts that we're going to look at is a radius, right? And again, some of this may seem like review. You learned a lot of this maybe in elementary school. I mean, you start in elementary school now and through middle school and high school, so you may have seen it before, but there's no sense in not reviewing. So in this case, we have a radius, which is from the center, so one endpoint is at the center, and one endpoint is on the circle. So one endpoint is at the center, and one endpoint is on the circle. So in this case, I want you to see how many different radii you can come up with. How many different radii can you come up with looking at this picture to the right? So I'll give you one. We have this one right here, which I did not draw accurately there. This one here, which is segment PC. Segment PC. Because again, it goes from the center to a point on the circle, meaning a point that touches this pink line around the edge here. So it touches this pink line around the edge. Okay? So P is the center, C is a point on the circle, which means one of them would be PC, right? So we could say then that this here is a radius, right? So this segment here is a radius. You hopefully can find more diagrammed here. There's also PB, again because it's from the center to a point on the edge, and there's also PA, right? All three of those are considered a radius here, but we'll keep PC up there for the sake of the picture. The next thing we're going to look at is something called a diameter, which a lot of you may remember is just double the radius, right? But it's specifically a segment with both endpoints on the circle. So both endpoints on the circle both endpoints are on the circle, and it goes through the center. So both endpoints are on the circle and it goes through the center. So the only one of those diagrammed here, A is on the circle, A is on the circle, B is on the circle, and it goes through the center P. So AB in this case would be considered a diameter. And it's the only one diagrammed here. So AB would be considered the diameter. You could also call it BA if you'd like, if you want to go the other direction. Okay? So that's kind of some basic vocabulary. Again, that may have been review, but there's more. Don't worry, we're not doing everything we learned from elementary school. But wait, there's more. There's also something we discussed that has to do with arcs. But before we move on to the arcs, let's look at one more specific thing. There's a term called a central angle, which you should remember from a previous video on regular polygons. The central angle is an angle formed at the center of a circle. So if I'm looking specifically at this middle picture, a central angle here could be viewed as angle RPS, right? This angle here is a central angle because it meets at the center, right? So angle RPS is an example of a central angle, okay? And it just has, a measure of some degrees. So let's say in this case that it's, I don't know, like 110 degrees. So the measure of angle RPS is 110 degrees. Well, if we are trying to describe any central angle, we would usually need to describe its measure. So the central angle specifically is angle RPS, and the measure of that angle is 110 degrees. Okay, so again, that's just an angle formed at the center of a circle. Now, if we're looking at this notion of arcs, we have, sorry, I just uncovered some writing there that I don't want you to see. An arc is a part of the actual circle. So in each of these pictures here, we have 3 pictures. In each of the pictures, we have each arc is illustrated in pink. Okay, the arc that I want you to see is illustrated in pink. So in this case, and I'm going to highlight it in pink as well, this first one in the middle, we're going to talk about this one here, this one I just highlighted here, that is called a minor arc. It's called a minor arc. It's smaller than a semicircle, and the semicircle again means half the circle, right? So this one is smaller than half the circle, it's less than half, so it's called a minor arc. Well, this one here on the right is called a major arc because it goes more than half of the circle. So this one is called a major arc. Again, we're just dealing with the very outside. If you're going with a pizza analogy, it'd be like looking at the crust, right? So a minor arc is less than half the pizza's crust. A major arc is more than half the pizza's crust. And this semicircle here is exactly half the circle, so you're consuming half the crust. Okay, so those are the 3 types of arcs that you can see. It's most common for us to be dealing with minor arcs. That's the most common one we're going to see. But occasionally, this one's the next most common, the semicircle, and occasionally they'll ask you a question about the major arc. Okay? One thing I want you to know is how to find, there's a weird notation where we call, like, again, looking at this middle picture here. I can ask you to find the measure of arc RS. And the way you annotate that is we write RS with an arc over it. So there's a little loop. It's not segment RS, because segment RS would be illustrated drawing a segment from R to S. That's different. Okay, that's different. Arc RS is when we go around the circle, we're staying on the circle specifically, and we note that with an arc over the actual letters. Okay? So the measure of arc S is the same, so equals the measure of the central angle. And what is the central angle here that forms RS? Well, in this case, it's RPS, the measure of angle RPS. They have the same measure. So again, before, if I said, measuring RPS is 110 degrees, then I would say that the measure of arc RS is also 110 degrees. So here's how these are connected. RS show the two parts that are on the circle. Well, R and S will just be the first and third letter of your actual angle, because what does P represent again? P is always going to be the center. So that value there is always the center of your circle. So the other two letters will give you the letters that are on the circle. Okay, so we say both of these, the measure of arc RS and the measure of angle RPS, we say those are both 110 degrees. Now, if I wanted to describe this major arc over here, if I wanted to describe the pink one, since it's a major arc, you need to include three letters. Okay, so major arc specifically, if I wanted to define this pink one, it would be the measure of arc. Well, it starts at R, it ends with S, so R something S. What letter? You need to name a letter that it goes through. So it goes through letter T, which means I'm going to put T in this middle space. Okay, so it's the measure of arc RTS will give you the measure of this larger arc. Right? So again, if we know that this is 110, well, the rest of it must be 360 minus 110, right? Which is, so if we wanted to find the measure, let's create some more space here to see this. The measure of arc RTS is just 360 minus 110, which is 250 degrees. Okay, so the minor arc is 110, the major arc is 250. But really what I just used here is this thing called a postulate. We used a postulate called the arc addition postulate. The arc addition postulate. Now this should remind you of two other postulates that have similar names. We have the segment addition postulate, we have the angle addition postulate. And the segment addition postulate, remember, if it says that the two small segments add up to the large one, the angle addition postulate say the two smaller angles add up to the large angle, right? So the arc addition postulate is going to say the same thing. It's going to say that the measure of arc AB, which again is here, arc AB is there, plus the measure of arc BC, which is here, right, the measure of arc BC, will give you the measure of the entire arc that I just traced. Or in other words, ABC, right? Or we could call it AC if we know that it's a minor arc or a semicircle, but we don't know in this case, so we can call it ABC. And if you're ever unsure if it's a minor arc or a major arc or anything along those lines, then just call it all three letters, right? Better safe than sorry. It's not wrong to say that. So that's what the arc addition postulate says, which we kind of used in this example here, right? This one here is 110. Let me show you what I'm highlighting here. This arc here in yellow is 110, and this arc here needs to add up to 360 by the arc addition postulate, therefore it must be 250, right? So that's kind of where that came from. Okay, let's see if we have something else for you. Oh, I just realized I wrote arc addition postulate twice. That was silly. So the circumference of a circle and the area of a circle. I'm going to go over both of these things in the next part. That's the only thing left on this video. Again, this might seem like review, so watch part 2. Shouldn't be too long of a video, and it'll be a nice refresher because we're really going to use these things to do some new things in the next section. So part 2 will be on circumference and area of a circle.